very small number of pieces of steel bar actually bundled, and view is from the side way. I'm going to show you how the data look like and what is the objective of this data. But before we start, the important stuff is that this small recap of YOLO. So computer vision in general. So in general, there are a lot of different computer vision models, right? We have a whole range of different models which are doing some stuff which are good. Some models are good in doing some things, and some models are very good at doing the other task, which means that it is very much depend on what type of objective or what is your end goal of doing something, and then you can select a model which is actually good for you. So a small recap very quickly that so for the object detection, for the image recognition or classification, we had in this data set in the long time ago in 2015 or somewhat, where we had deep learning model called convolutional neural network. So then those models were actually trying to, I'm not going into the detail how they work, but mostly they were trained to crop the image pixel to pixel and then try to guess what it is at the end of the day. So then came a lot of different innovation in that stuff. Like after the convolutional network, there were recurrent convolutional networks like RCNN and fast RCN. The problem was that it was very computationally expensive, because it essentially, under the hood, what it is doing, that it was cropping the image into the multiple boundaries in the end, and then it was trying to in the background run multiple convolutional network. First, they trying to achieve the region of interest, and when they make sure with one model that this region of interest could be the dog or cat, then they crop that region of interest and then again run second model to detect that what it is inside. Essentially, that multi-layer style of networks or model made it very, very difficult or need a lot of computational resources. For that, actually, there are a lot of innovation work going on, and one, the Joseph Reed-Moon and the co-authors, I forget the name, they try to come up with the idea that you only look once and try to get the probability where a certain image is. So then came the innovation in mind, you look only once, like YOLO. So the journey of YOLO is started somewhere in 18 or 17 maybe, but after that there are a lot of different people, a lot of different community trying to work. And the most recent one is the Ultralytics. These guys are really came up with very smart ideas. First, they convert the, the original author of YOLO somehow chose the C++ and darknet model for YOLO, but that was really hard in the Python, because many people who are doing machine learning or Python, they are good at Python, and there were a couple of wraparound stuff, but YOLOv8 and after that Ultralytics come into the picture. They actually wrote this model natively on PyTorch. For native for the Python, there's no need for wrapper, and after that they have came up with a lot of innovation on top, which means innovation there are many different, there is motion detection, there is segmentation of any boundary, there is detection, there are like, these are the three main tasks of these models or innovation they came up. Other than that, they came up some architecture wise innovation. Today we are going to use in the 2024 the latest model available, which is YOLOv8. So let's look into the data. So here is the data actually, which you can in that annotation and image. So this is the image look like if I view here, something like that. So these images are essentially a bundle of the steel bars. I don't know how you call it, like steel bars, which you use in the lintel and other stuff for the construction. Actually, they are packed in this outer shell, and these are the bars, and we want to count them, how many number of these. So this is the end objective. So we get this data from somewhere from the research paper, open source. Right, great. So data looks good. And there's the annotations. So indentation. So this is not relevant, but I can just show you how these files look like. If you open any one of them, so this is the bar, this is is the size of these bars or steel bars, but this is the number name. Here is the name of the image file, and then here is actually the coordinates relative to image size. So there's a big problem, or not big problem, but there's a small problem we need to address. So the problem is that YOLO format is quite different what we got here in the dataset. The first thing is to convert actually the dataset into the format which is readable, understandable, or minimum workable for the YOLO. So let's get into it. Okay, I have written this function here. So I want to give the path of the text file, and then this function is going to convert this. What it's doing actually, I can just show you with maybe this bar here. This is the coordinate x, y. Okay, and x, y rectangular. So there are 4 coordinates, and the coordinate means that we have here image. The origin is 0, 0. So how much we travel to the in pixel to the x, and how much we travel in with respect to y, right? So then we get the point x, y, right? To create the rectangle, we need to go from that area further in x, y direction to reach there. So this is actually that area. And this x, y is simply where from we're gonna start. So for example, this is the image, right? So okay. So what we are doing this, we are actually taking the average and multiplying it with the width. And again, we are taking this area here and multiplying it with the uh, so taking the average actually simply with respect to the image height and width, and then we go to center in this way. And we simply when max and minimum and divided by the width, and y max and y minimum divided by the height of the image, and then we easily get the relative points, right? And after that, then we can center 1, center 2, width of the bounding box and height of the bounding box. So then we can easily get this thing here, the call bounding. Sorry for the drawing, my mouse is not working today. So yeah, that's how we wrote this. So let's do some further from stuff, and then I will show you something here. Okay, everything remains same, this remains same, everything remains same. The only stuff is that we make the code a little bit efficient, which means that we introduce here a dictionary. And why we introduce a dictionary? Because and secondly, we introduce actually this slicing of the text image. Why we need slicing? Actually, it's too big, like it's 179,000 rows, and you know, even I have very powerful and good computer, like with a lot of RAM power, it's still struggling to advance processing everything because it need to open a lot of image. So the major problem we got here is that we need the width and depth of the image, or in other words, the resolution of the image, which means that we are either we just have to note the resolution itself, but what we are doing, we are opening with OpenCV, and automatically we are getting the image.shape. The only way to get the image.shape is to first open or load the image, and as you know, that image is the color with 3 channels, means that it has a lot of big matrices inside with numpy, and it has like 3-dimension with a lot of rows, right? So that's why it's a kind of glitch here, that the data is not well prepared or prepared for something else or some other problems, and you need to manipulate such a big data, because the bars actually sometimes they are 200, they are 150 or something like that, and you need to calculate the bounding box as well, like for 150 time or 200 time per images, which make it a little bit time consuming as well, and computational hungry as well. So what we can do is that we can divide this into chunks, so at least we get something great. Everything looks great. The next change is that we forget that the class label is always numerical in the real data, in the Coco dataset, or if you see the repository GitHub of the YOLO, there's just a class label in the numerical form, because somehow it doesn't, the software doesn't understand the text. Later on we can convert, we can give any name to the one, or vice versa, but yeah. So that's why we were forced to do some changes, and changes are not much, too much changes. So the only changes is that introduction of dictionary. First calculate everything into the dictionary. So it is kind of more simple, that if the image name, whatever the image name is, so image name is nothing but the first first element of row first. So this is actually dictionary of the dictionary, as you have seen previously. List of the lists, right? List and list. So CV data, if you hover on this, it's saying that list. Inside it is list, and then it's string. So similarly, we have got the string actually already. and everything is same. The second thing is that we are telling that if image name is already not in the dictionaries, so create a key. So the thing is that uh, the another idea or the greater idea to do this task is to create a dictionary with key is equal to image name, whatever name it is. So like that, this is the key, and is equal to empty, is equal to list, right? So dictionaries are very powerful things. You can store any tuple, any string, or any list of list or sublists. So for any corresponding key, they normally follows the structure of key value pairs. You already know. So what we have done is that we have actually created. I mean, it's not also very efficient way of doing this, but we are running short of time. We don't have much time to consume to write it very efficiently. So this means that you first actually write the whole names for during this process. First row as a name, and then you read the image. That's actually where it's consumed a lot of resources because it's read the whole image from the path. And as you notice here that the image full path is the join of the image path, like base path, which is up to the image. And by join, we are appending or we are adding this image name, whatever we got here, to the path. That's gonna search this path into the image path, read it, get the shape done. We need shape here for width and height in our function. Now we are doing a little bit of shortcut here that we are saying that YOLO data dictionary, right? What we have our save here, YOLO data dictionary here, and we are appending with name. So image name is already the name, same name we have introduced a dictionary with, because in dictionary there is already an image name is same as what we are writing here, like same name. Against that name we are appending data, because if you see that it's returning this stuff, or a dictionary of this stuff, right? Which essentially means that it's a kind of string actually, and this string is in shape of list, and in this list we are adding that. So right now it's empty because we also can write here none, that it could be anything, string, tuple, whatever we want. Right now when we write the append, it's automatically append the dictionary, but inside the append we need to write text. Instead of writing text, we are writing function, which in other way doing his stuff already, here, and in the end return the string. And similarly you can see that for each image, for the each row, it's come down, it's write the dictionary name, dictionary key, and then it's append in front of that key this image here. And it's trying to loop over until and unless this loop, which means that CV data is 179,000, but we have stripped this, or we have split this into the, we have sliced this into whatever we want to write it, like 10,000 chunks. Let's make it more easier, and we are getting some stuff, and we don't have to sit in front of computer all the time, right? So in the end, it's very simple. So for any image, actually, if you're going here, and you're assigning two names, whatever names you want. Here you can write anything makes sense to you. And when you're, this is the method of dictionary, right? And this is actually whatever dictionary is giving you the string in one's way and the list of items, whatever you have written here. So what you can do is here is that you can say that this is the image path, okay, and image name, the same stuff, right? Because it's kind of easy for me right now. I need to change it later on, but it's easy to do it in Linux, so, right? But I could change here. I can here write a join and base name and trim the text already. But just to make it easy, that we have one path which is image, and we want to have same label, right? And what I'm doing is that I'm just getting the same image path name, right? And in the output path file, I'm just appending this file name, right? So what's happening here is that With this image path full name, we need to read the image first, because kind of we need again the shape, and we are opening here is file, and we have already YOLO data list, right? So data is just one single line of string, and we are putting this new line here so that it's always right new line here, and as simple as that. So technically we don't need do we need somehow, yeah, actually to we need this I don't know why we need here's that thingy. Might be I have written this for showing the image later on, but right now we are not showing any image, so leave it. It's up to you. You can leave it, and it's doing nothing actually here. Yeah, that's all. That's all we are doing here. That's what we have written here. And there's one problem which is to be solved, is that if I click here, here's the bar. So how I can solve this problem is with sed, actually. With sed, we can solve this problem. So we have multiple way of doing this. One way, easy way, is to git bash. Git bash is give you some functionality of Linux or Linux GNU shell, some built-in functionality already over the window. Nowadays, Windows is also compatible with WSL, which means that you can install Ubuntu or whatever operating system you want from the Microsoft, and it's do the Linux virtualization, and on the virtualization top, it's using the kernel of Windows as a resources, but it make the kernel of Linux in the end, where you can do a lot of stuff. You cannot go very down the line. It's very low level, which might be you don't need, but most of the stuff actually you can do with WS. Yes, I can show you here. I have Ubuntu, and I click it. I have WSL, and the beautiful thing is that for the higher version of the window, like 10 and later on, you have file system of Windows always. So if I click here, and if I could show you monitor of my screen, you can see that there is the Linux file system. If I click on this, I can get Ubuntu file system as a native. That was kind of very hard before that, but right now it's not that hard. All right, we have problem in hand. We have resolved a lot of problem already with respect to data, but as you see that whatever files we have a problem. I can just get any single text file, and you see here's a bar. But in the original file, we don't need bar. We have done this mistakenly, but we cannot rewrite whole images because it takes a lot of time. Other we have, and there's one problem which is to be solved, is that if I click here, here's the bar. So how I can solve this problem is with sed, actually. With sed, we can solve this problem. So we have multiple way of doing this. One way, easy way, is to git bash. Git bash is give you some functionality of Linux or Linux GNU shell, some built-in functionality already over the window. Nowadays, Windows is also compatible with WSL, which means that you can install Ubuntu or whatever operating system you want from the Microsoft, and it's do the Linux virtualization, and on the virtualization top, it's using the kernel of Windows as a resources, but it make the kernel of Linux in the end, where you can do a lot of stuff. You cannot go very down the line. It's very low level, which might be you don't need, but most of the stuff actually you can do with WS. Yes, I can show you here. I have Ubuntu, and I click it. I have WSL, and the beautiful thing is that for the higher version of the window, like 10 and later on, you have file system of Windows always. So if I click here, and if I could show you monitor of my screen, you can see that there is the Linux file system. If I click on this, I can get Ubuntu file system as a native. That was kind of very hard before that, but right now it's not that hard. All right, we have problem in hand. We have resolved a lot of problem already with respect to data, but as you see that whatever files we have a problem. I can just get any single text file, and you see here's a bar. or in the original file, we don't need bar. We have done this mistakenly, but we cannot rewrite whole images. What we can do is we can use set, and we can see that manual set, main set, set main. Okay. Uh, okay. Is there any way to actually replace the in place file pattern? Quiet force, foreign symlink. Oh, AI suffix in place suffix. Enter the file in place, make backup supplied. Great. So what we can do is we can okay, we can also write regular expression here, which means that it's easy. How much number of file we have? We have always, if we ls, we have always file with extension txt at the end, right? We can then give, we can experiment. Otherwise, we need to rewrite everything from scratch again. So let me just do set I. And okay, first I need to look at set help. Oh, regex. So okay, set I. Okay, set I in place, and we can actually do this always when we write a regular expression, because then don't consider is go character wise. We can, as I used to do a lot of regex in past, and regular expression is coming from the Unix operating system style, and it's very low level, but yet very powerful. And here S means that you want to substitute whatever found here. Well, great. Then actually, this is the common syntax always of set. And if I write n actually, as you can see here, n, normally set give you the whole output of all files, but you need to always write n or I or whatever suits you to do stuff. Otherwise, it's gonna give you the whole output of whatever written in the text file. So this is the common pattern. And since we are doing the here the normally you need to do p here as a parser, which tells system that this phrase you want to search. If you write n instead of I in single file, in a single file search, there would be pies. But here we are doing regex, which means that we need to put double inverted commas or single commas or single quote, and in single quote we need to write regex. Now, as you know that regex has this bracket, you always start something expression with this, and b. Why I'm doing b? Because I mean, like, omit this. This is better to do this because whatever I would write in the bb, it says text boundaries. It's always see that b starts bar is a start of the word, like it's after space always. Why is it doing this? Because normally um, if bar appears in the center of any single text or any word, like bar, barrier, or like something else, BARIR. So it's then gonna split this word within the text, which we don't want to do because we only wanna search a whole word. Okay, then our word is the bar actually here. We said that if the boundary end, and if you find something, right, whatever you find inside there, you replace it with 1. Cool. And then I'm saying that please do it as a global. Global means that as many as number of time you find this, you do this. It's global search always. Oh, then now I want to give it where I need to find. I need to find it here, not in the other directory, and I don't need to write path then. And it's very easy for me. Otherwise, I had to again write wildcard. If you know the wildcard, In Linux, like there are many wildcard, this one or many others which are used to search the file, or this one sign of question mark to omit the word. So what I can do is here the life is easy for me because it's very simple. Whatever you find here, regardless any word, whatever it is, before txt whatever appeared, but it must have to be end with txt, and then it's gonna search everything globally. It's gonna match everything. Let's do this, try and see if it's okay. It says that okay, said e expression 1 command s. It shouldn't be the case, but let me just figure out why it is so. I guess here is a slash, right? Okay, it has done something, and let us just do get rebar slash 1 whatsoever. There are many possibilities here. Okay, then let's just quickly check something with Control C. Get Shift Insert. Okay, beautiful. Superb. That was our last file, or at very last end. See how powerful this Linux is. So we are good to go. Now I will tell you how to train a model and count the bars later. Okay, now somehow we have data available already with us. So a lot of data is here. So now we'll see that Ultralytics official provider of YOLO V8. We can actually see that what's there. That's what they actually suggest to make you data about. So well, great. What we're gonna do is that we're gonna prepare the data in a similar fashion. Great. So this is actually a YAML file which we need to create. First, we need to create a dataset. Okay, great. So first thing first, we need to clone this repository. Let me just try to clone the repository first. If I go to somehow where here, this is the official one, https git clone. So if we are on window, we especially need git actually. Okay, or maybe we can do this here on terminal. Okay, we are in our virtual environment, and we are here in this folder, which means we have dataset everything. Can we just clone this on top? Git clone somehow. Okay, great. We have now in Ultralytics somehow everything is good here. Can we install run? Okay, we cannot install or run Linux command here. Linux is always good, but okay, I don't know. No Linux command here. Some of them gonna run, most of them not. Let's see if pwd is running. Okay, pwd is running. Reva now something that's what it's showing main here. Don't worry about that. We need to find all the JPGs and remove this. So set in place replacement double quote double slash. Then we want to substitute this, and we want to replace it with nothing. We don't want space here. Should be global. And text boundary. I mean, we don't need boundary here because, you know, Okay, but it's not in the file, right? We need something else here. We need something else actually. I think so. It should be, but there's somewhere else. You rename, let's say like that. Double quotes. It's always starting in with these forward slash. Dot is the special character because we need to see JPG, right? This is what we want to. Dot JPG, dot text. Again, dot is special character. You need to escape it with the backslash txt. Um, that's what you need. And then you want to somehow replace it with .txt, which means that, and this is then end. So, and we wanna find everything that starts with jpg.txt, right? This should rename actually .jpg. Forward slash tell is that's this is the end of expression one .txt jpg.txt rename. I guess we need to write somehow substitute here. Substitute find dot jpg. This is again, I guess, backslash to escape dot text. This is the one whole expression we want to find. Slash replace with dot text. And I guess this should do the trick, right? Find all the file with this extension, whatever the name is, but in the end there should be .jpg. And if we do so, this should remove or rename the file. Okay. Rename actually is not available on git bash. Life is not easy. We need to find something else because rename isn't working. Maybe I can check Ubuntu. Rename sudo apt. Okay, we need somehow Ubuntu, but how we can go there with Ubuntu? Normally it is mnt c then c user no user. Why cd users? What the heck? Cd users, cd happy, cd pycharm, p is capital, pycharm. Why on earth? cd pycharm projects, cd zupon. Oh my god, cd ultralytics, cd ultralytics, cd ultralytics again, cd datasets. That's, oh my gosh, so long path. cd labels and Kidoki here actually. Okay, somehow we have restarted everything and try to install a CUDA code toolkit here. We need to again check it and verify it. So we are not in environment anymore. Means that, can we now check actually? here because actually kind of we are out of right now. Need to source and activate this first. Taking long. Still not. I don't. So let me just do this. Nice, nice. So as we have run this check, and now we can see that our model can run on media, and we got 8 GB of our memory, which is already great because GeForce is already a kind of advanced model which could support actually could update from up to 11.7 or 8 already. And it won't, one thing that it won't actually support CUDA 12, which means that if you're a Windows user and if you normally install CUDA, it's automatically installed 12 and you want to be able to run this. And this took me some time to figure out. So great. Now the next thing next, we trying to run some model and come up with some inferences. Okay, great. Okay, now let's run this. Let's see here. It says it's 72 images or loaded. Where it has 24 images, 26 images. That's right. It has created a new cache for training bed. And then let's see what does it. It's a pre-trained weight from motivation already here with physically that's probably data compatibility. So we have to actually ensure that your table, the size and the file and how the formats and everything should be completely connected. Otherwise, that's not good. So okay, guys, great. So our training is finished and our results are somewhat better here. We can see here the confusion matrix. I'm not going to go into much detail. Well, as you can see, there are a lot of training has been done here, like multiple checkpoint to save. And the good thing of the model is that it has great ability to resume always. This is which is very good thing. Here I can see that this is the last batch training. And if I see here, it's a beautiful matrix here, which shows me a lot of information here. I can see a lot of stuff here. For example, accuracy and a lot of other stuff. Like you see the precision level, so very high, near to 85%. We have only one class. So yeah, this is the recall. Recall is always very great. So recall means that if there are more than one instance or occurrence of the class, whatever class you have, does it counting all or is missing something? So recall is also great. Well, confidence score of recall is also very great. Here's some batch during the batch taken validations, which is already good. So I have run validation command here, which is here, this one. So this has created automatically this whole stuff here. As you can see, labels and stuff and everything. So it's working great. So precision is good, recall is good, accuracy is good, F score is good, and mean average accuracy is good. Learning rate drop was really great when I seen. So overall, for the 100 epochs, it's kind of good results right now, I would say. So let me just then. So what else I have done? I have done here that I have already collected some validation images. I want to save them on the list to see that how they look like. So here we see that we again use the join method to do this to get the image path, and here we are setting counters. We get, as you can see here, everything worked great. So let me just check how the results comes. So I have written the save file to save the result to see how the boxes are looking like. So we'll see the boxes how they works, and then we can do some extra stuff like we can count them, how many number of results we got, like how many number of bars it's counting or not. Let's first check the result. Here I'm in dataset actually. Here I have saved something as a predicted here. And if I view this medium large or fully large X, yeah, you can see it's working very fine. I could open it here like that. So it's calculating stuff very well, I would say. Here's a little bit more cleaner version because the higher mm diameter of this bar is showing more visible. As you can say that it's always trying to only plot if the accuracy is higher than 80%. You can also adjust this during the results, what type of accuracy you want. You can also see here, right? Somehow it's doing a great job, I would say, overall. So let us then do some practical example where might be you need to count these in real time. This model can also, if a video is passing through our camera is getting a stream feed through this loading process or whatever practically it is, it can give you the count of all bundles that how many for the quality check or whatsoever. So this could be a possible use case. Even the second good thing is that, so as you can see, the stuff is working great here. This you can see as well. This you can see as well. This you can see as well. So it's kind of work great. So yeah, let me just now do counting mechanism. Okay, okay, guys, we have done our training, and now it's time to produce a result that whether we are able to do something or not. For example, font size, I don't know what color it is here. Thickness could be 2.5 here. Yeah, which means the thickness should not be in 2 or 2.5, it should be 3, right? Okay, so here's what we are doing. So nothing fancy. So a simple stuff is going on here. We have done our training, so we don't need training anymore. So that's why we have comment out this part, very simple. And we have wrote another function. The function is quite simple. What function is doing is that it takes a model path where our train model, whatever weights we have got here, and then image directory is here, and output where we want to save our results. Then great. So this is the simple function which is actually taking this like path, image, and this, and loading the model, getting all the name. OS path.join means that it's joining the path like image name with the path to make a whole relative paths. We are printing to check this, and then very simple model image list. So we have load model, and we can give any name, and now we are listing this. So we are counting this to 0 before that loop because we have multiple images right here. It could be any number of images. So for each results, we are just simply thankfully YOLO team in Eldolatic, they have like make object of everything when it's come to result, and this object is quite handy for you. Like here, as you can see, you have boxes, you have key point if your model is key point, mask if your model is mask, your class name here, BB OBB bounding box. Like it's a different technique than normal bounding box, so it's more accurate and a little bit more fancier, but in result you'll be same. This is the original image, whatever image you have supplied, the matrix of that image, and then dimension of that original image, path of that image, probabilities, save directories if there is some, and some inferences stuff is given here. Quite simple stuff here. So what we are doing is that we want to count actually boxes. Simple stuff, we just give length of that. We save it first because there is no other way around, and we again read it and then put some a number of the count of on the image, right? There are some other way or more efficient way to do this, but right now we don't have much time here. We're gonna run this here. Hopefully this runs. Looks great. This is what we have printed the image path to see. Great, as you can see that for every images, it's already giving us the count, kind of count in the pre-processing, and you can get this count as well, because those pre-processes and the stuff what we have seen above in the result was the placeholder, and in this placeholder now you can see that there are 135 bars. Okay, this is the dimension of image, this is image number 2, 3, 4, 5, 6, 7, and it's giving us a complete count here, number first, which is a beautiful thing. Second, we can go to the prediction folder somewhere here, and we can check what's happening here. Oops, it's the 135, 250, 150, 112. Ah, this font is a little bit bigger, right? 229 and super 45. You see, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Even it's very hard for a human being to count it. But you see how beautifully it's counting. Let me just put this 45 a little bit smaller font size and a little bit lower. Yeah, but I mean, you have the idea what's going on here, right? 160, 111, right? And yeah, and these data we didn't supply it for training. So yeah, that's how it works. It's great. Model is working fine. That's how you can do a lot of stuff with YOLO. The beautiful thing is that this is the raster image, but you can do this in video streaming where you can count everything in live. For example, something is going on, and
you can count forward, which is already very great. So yeah, keep watching. Thank you very much. Bye.